Okay, hello everyone, so Afi here. So let's try to do this question. So we have a car which is traveling and it counted a bump. So obviously we have tangential velocity when the car hits the bump. Okay, I can just list down the important information. We have the 12 meter per second and then radius of the curvature 35, right? Okay, and then the weight of the person is the mass of the person is 67 kg, but we want to find the apparent weight. Okay, the weight that is this person appear to be. So when we talk about apparent weight, one thing that we know is we need to find the normal force. Okay, that is the thing. Normal force is the force that is pushing up on you. So that kind of force varies according to the situation. Okay, if you are on a bump, for example, you will have less weight because of the circular motion in comparison when you are moving properly in a linear kind of road. Okay, so our intention is to find apparent weight, which is the normal force. So let's try to draw the free body diagram. So let's say the free body diagram of the car on the bump here. So we will have normal force going up, and then we'll have weight or mg going down. Okay, so this is how the free body diagram looks like. So now we know to find normal force, we can just use the Newton's second law, but this is related to circular motion, so we use F total FC centripetal force equal to mv square over r. Okay, and then we can just know that FC here we have normal force and force due to weight. Okay, I favor to make every force that is going into the circle to be positive, so I just put a W minus N equal to mv square over r. Okay, so now I know I want to find my N, right? So I just rearrange this equation. I will get something like this: AW minus mv square over r, and we know what W is. W is mass times gravity. So mass times gravity is equal to mv square over r. Okay, so now I want to find my normal force. I will just insert all the values. So my mass will be 67. Okay, I just factorize so that it is easier for me. I factorize 67 times 9.81 minus 12 square. Okay, because we know 12 meter per second divided by 35. Okay, and then it turns out that the apparent weight or normal force is equal to 380 Newton. Okay, so this apparent weight here is 42% less than the normal weight. Okay, which is normal weight 67. Time gravity, you get 660 Newton. Alright, so that is the first question. Move on to this here, second question. Referring to the same problem, at what speed must you go over the bump if people in your car are to feel weightless? So now we want to feel weightless. So when we talk about to feel weightless, we need to know, we need to make one force to be equal to 0. This is the same thing happen when we want to find the minimum velocity, right? So this is just the same thing here. So weightless, normal force equal to 0, so I just put the same here. FC equal to v square over r, and just put mg minus n equal to mv square over r. Okay, I tell you to make it weightless, n should be equal to 0. Then we will left with this one. and it turns out I can just eliminate m because we have m at both sides, right? And then I can just get my v, the speed, to be square root rg. Okay, so square root rg, radius is 35, gravity is 9.81 in this particular situation here, so we get 19 meter per second. Okay, so that will be my final answer.